हेलो राहुल।
हाँ मैडम,
हाँ, आ रहा है आवाज भी मेरा?
आ रहा है मैम, लेकिन मैसेज आ रहा है नेटवर्क बैंडविड्थ इज लो, ऐसा बता रहा
हाँ,
है।
मुझे भी ऐसे आ रहा है। मैं भी जियो पे ट्राई करती हूँ।
यस मैम। हाँ हाँ मैम,
अभी ठीक है?
नेटवर्क नहीं, नेटवर्क लो है बता रहा है मैम, बैंडविड्थ लो है।
अभी एक मिनट में देखो। फिर मैं जियो पे लगाया है मैंने।
स्लो। डबल आ रहा है।
हेलो
यस मैम।
हेलो,
हाँ मैम, आपका वीडियो पॉज हो
आवाज
गया
आ
है।
रही है सर?
आवाज आ रहा है, वीडियो पॉज हो गया है।
हेलो
यस मैम।
राहुल, आवाज आ रही है?
हाँ आवाज आ रहा है, वीडियो पॉज हो गया है मैम, वीडियो पॉज हो गया।
हेलो
हाँ मैडम।
हेलो। अरे आपका स्क्रीन है ना, एक ही स्टिल इमेज आ रहा है। नहीं, अभी मैंने जियो लगाया तो अभी तो नहीं आना चाहिए प्रॉब्लम।
आपका वीडियो नहीं आ रहा है मैम।
हाँ, मुझे वो एक मिनट, क्या करें फिर अभी? जूम में वो तो प्रॉब्लम आना तो नहीं। अभी भी आ रहा है? एक मिनट, फिर मैं इससे करती हूँ फिर एक बार हॉटस्पॉट से। अभी आ रहा है? अभी आप तो दिख रहे मुझे। अभी भी? नहीं नहीं नहीं, आप क्या अभी कुछ कर नहीं सकते। एयरटेल का इंटरनेट जो हमारा है ना, फाइबर का, कल से वो बंद है। आज उसने बहुत बोलने के बाद शुरू किया है, वो भी लो है। मैंने एयरटेल का हॉटस्पॉट दिया है मेरा, तो वो तो चलना चाहिए। जियो भी लगाया है। Hello, Rahul.
Yes, madam.
Now check audio and video.
Yes, ma'am, एकदम clear है.
ठीक है ना?
Yes, ma'am.
हाँ ठीक है, फिर म्यूट करती हूँ. मैडम को मैंने 2 बार फोन लगाया, अभी उठा नहीं रहे हैं. 5
Okay.
मिनट में हो जाएंगे ज्वाइन.
Yes, ma'am.
थोड़ा सर ज्वाइन होते ही आप बोलिए, फिर मैं अनम्यूट हो जाता हूँ.
Okay, ma'am.
I
Sir, good morning. Good evening, sir.
Good morning. How are you?
Fine, sir.
So you could have both my audio, video.
Yes, sir.
Oh, okay.
Hello, Dr. Gudivada, sir.
Yeah. How are you, Dr. Archana?
Fine, fine. How are you now? How's your health?
Yeah, I'm doing fine. Yeah.
Hello.
Right.
So now everything is fine?
Yeah. I can see barely your video. I think it's on and off, or it's very shaky.
There are some network issues.
Yeah. So that's fine. So nice seeing you.
Since morning, Airtel is troubling us. Service provider.
Right.
And here a monsoon has come, no?
So you're getting good rain.
Not yet good in Nanded, but in many areas of Maharashtra, it has started nicely.
Oh, okay.
And
So,
Nanded yet to start properly. There are few rains here and there.
Right. So we get a lot of rain. Actually, we got so much rain. It's almost like every day we get rain here in summertime.
Is it?
Yeah, it's quite it's hot, but again, compared to Nanded, it may not be as hot here. But still, I think it's quite hot.
Okay.
Right. So looks like you have quite many participants, 145 is going up.
Yeah.
Oh,
Few
okay.
more will join in 5-10 minutes.
Oh, okay.
Uh,
So what
Yeah,
is
we are.
yeah. So you can tell me what the schedule is, like how long should I speak? And I don't want to, like last time maybe we ran out of time.
No problem. We enjoyed your session. You can
Oh.
extend till 7:30. No problem.
Oh, okay. So you're all still under lockdown?
Yeah. Till 30th June, there is a lockdown.
But 30th June is coming soon.
Yeah. So probably it will be extended for the schools and colleges.
Oh, okay. So you may not go back to, like the new academic year. You may
Yeah,
have to
not
do
daily.
online.
We have to go for administrative purposes.
Right.
Students will not be coming to campus.
Right. But as long as faculty maybe you could maintain social distance, it's not a problem. But when students are on campus, it's going to be an issue.
Right. That is the reason that government has not yet announced date for the schools and colleges.
Right. I think for us, everybody's rushing to reopen universities because otherwise students may drop out or they may go to some other university. But I think it's in the US is one of the countries where it's increasing every week. We have more and more cases.
Yeah.
So it's people are really worried, but at the same time, it's not good for economy.
Right.
So in the sense that some people have money, but if this continues, a lot of people would not have money, and what will they do? Poor people and people who really depend on daily wages.
Yeah.
Right? So that's a big issue.
Same thing is in India. And that is the reason that they have opened partially lockdown to boost the economy.
Right. So, I'm just at your disposal. So whenever you want to get started,
Director Madam also joined.
Oh, okay.
We are just waiting for Director Madam to join.
She joined.
Good evening.
Yeah, good evening. Good to see you again.
Good evening, Madam.
Good evening,
Right.
Good evening, sir.
Yeah,
Good evening,
How are
madam.
you?
Yes, how are you, sir? How is your eye?
No, I'm fine now. I think it was just a freak accident because it just happened the night before. But I'm back to normal. It took me 4 or 5 days. I had little blurry vision,
Yes.
but now I think I'm back to normal.
Good.
So
Nice to know.
yeah. So nice seeing you all.
My granddaughter also had this habit of, she used to pierce her nails through, and like her mom used to have all her cheeks, marked with her nails.
Right. Cheeks are at least, it's not as dangerous.
I also got the prasad couple of times, not more.
Right. So you're all doing fine?
Yeah, we are all doing.
Right, wonderful.
Oh.
Shall we start, ma'am?
Yes, we can.
Samruddhi, are you there? Samruddhi?
So these are very likely the same people that we had last time?
Yeah, so audience is almost same.
Okay, yeah.
Over to you, Samruddhi.
Yes, sir. And all present here. This is Samruddhi Deshpande wishing you all a sparkling welcome on behalf of MGM's College of Engineering. Present here. This is welcome on behalf of MGM's Respected Director Madam, Dr. Mrs. Geeta Latka, Head of CSE Department, Dr. Archana Razurka Madam, all the dignitaries, our distinguished speaker, Dr. Venkaten Gudivada, participants, teachers, and dear students, a hearty welcome to you all. After our last successful webinar by Dr. Venkaten Gudivada, here we are with yet another webinar by Gudivada sir. Department of CSE feels privileged to present this today's webinar, Interpretable Machine Learning with Probabilistic Graphical Models by Dr. Venkat N. Gudivada from East Carolina University, USA. Dr. Venkat N. Gudivada is an academic leader with deep conviction for student success, serving the public and regional transformation. His experience spans a range of higher education institutions with different missions and goals. He had developed several new degree programs in computer science, software engineering, and data science at both undergraduate and graduate levels. Presently, he is professor and department chair, Department of Computer Science, East Carolina University, USA. To commence with deep honor, I request Dr. Archana Razurka, Head of CSE Department, to present the of today's national webinar.
Thank you,
Archana ma'am.
Samruddhi. Thank you, Samruddhi. Today's eminent speaker, Dr. V.N. Gudivada, who is Professor and Chair, Department of Computer Science, East Carolina University, USA. Our beloved Director, Madam, Dr. Mrs. Geeta Latkar, my colleague, faculty friends, and dear students, a very good evening to you all, and good morning to Dr. V.N. Gudivada, since it is morning in USA. First of all, I would like to heartily welcome you all to the third international webinar organized by our department. I feel proud to state that this is the fifth webinar in the Tech Talk at MGM-CEN webinar series organized by our department to make the students' COVID vacations more meaningful, more fruitful. So today's webinar has been organized on the topic Interpretable Machine Learning. So friends, what is machine learning? Machine learning is an application of artificial intelligence that makes a system which understands, which learns from its experiences, which improves from its experiences. The primary goal of machine learning to make computer algorithms to learn automatically. This terminology, machine learning, has been introduced by Mr. Arthur Samuel, who was working in IBM in 1959 in USA. Machine learning is one of the hottest today. Since 1959, intelligence and machine learning, specifically exponential, the whole IT industry is looking for this exponential growth of machine learning. And nowadays, in every application, in every field, machine learning and AI are going to be used, which makes the system to learn from the data, to learn from experiences. According to the recent Gartner's report, artificial intelligence will create around 230,000 jobs by the end of 2020 in the area of AI and machine learning. LinkedIn's 2017 report says that there are 10 times more machine learning engineers working today than 5 years ago. So friends, our today's distinguished speaker, Dr. V.N. Gudivada, is going to deliver a webinar on today's cutting edge technology. My heartfelt thanks to Professor Gudivada for accepting our invitation in spite of his busy and hectic schedule, sparing time for all of us. Last time, his webinar was scheduled on 14th June. but because of some medical emergency, we had to cancel that scheduled webinar. But immediately, as soon as professor was okay, after 3-4 days, he immediately contacted me and requested me to reschedule the webinar. I only told him that you take your own time, first be okay. Today's date has been fixed for his webinar. Then my thanks to Director Madam for all the time providing her support, all the time providing her motivation and inspiration to organize various activities in our department. Then I thank our faculty coordinators, Mr. Rahul Singh Bisen, Mr. Satpal Singh, Mr. Junaid Khan, and faculty and students who have been all the time working hard to make these students' COVID vacation holidays more fruitful. Samruddhi, over to you, Samruddhi.
Thank you, ma'am. Throughout life, we have often heard that perseverance pays off. It is no secret that each generation wishes to nurture and raise the next generation in a way that is greater than themselves. And to do this, elders often teach the values of hard work, focus, dedication, and perseverance. At MGM's College of Engineering, our respected Director Madam, Dr. Mrs. Geeta Latkar, always makes sure that the students should learn all these values along with the academics. It would mean a great honor to request Dr. Ma'am to guide us with her wisdom words on this webinar.
Yeah. Good evening, Dr. Archana and her team. Good evening, students, and good morning, Dr. Gudivada.
Good morning.
It's a matter of pleasure to have you back here. Last time we had to postpone your webinar, and we are very glad and happy that you made it possible again to be there with us and give us the pleasure of hearing you and enlightening our students. As we said that everybody keeps selling on himself or herself all the time. Okay, whenever we enter into the professional life, we have to keep selling ourselves. And to sell ourselves, we like ourselves, that means our ideas, our thoughts, our leadership, everything. We have to convince others to follow that, like we have to make the team and we have to take care of the performances. For this, we have to create our own unique selling points, USPs. So what is it that you have so that you are acceptable in the market? What is it that you have? What is your potential? What is the edge over that you have given to your students? And that is the question. And this edge over is being given by MGM family with the webinars like Dr. Gudivada sir sharing his thoughts with our students. Okay, I had shared a story of Japanese people who love eating fish. Okay, so Japanese always, okay, they will be taking their launches going into the deep sea and find out very good fish, get the fish back to the shore. But by the time they get back to the shore, they used to find that this fish has become stale and, stale, and it's a couple of days old, and then it doesn't taste as the fish would have tasted. Then they had this liking for fish so much that they wanted to have this fish very fresh, so they were worried that what could be done. Then what they started keeping some water tanks on their launches. Okay, and they caught the fish, put into the water tanks installed on the launches and get back to the shore. But even then they found that because the fish is lying idle in the water, it has again become stale by the time they got back to the shore. So then they were like applying their mind and having some ideas. Then they had the idea of putting couple of sharks in each tank, small sharks, of course. Then these sharks used to chase the fish, and fish used to run with all their energy and vigor inside the tank. And like even if they came back to the shore, fish used to be active and hence fish used to be fresh. So, we always have to have sharks chasing us, okay, the urge of learning new things chasing us so that we keep ourselves fresh, and then we become sellable, and we become interesting, and we become acceptable to all through our life. So, like, for keeping ourselves fresh with the latest technological concepts, Professor Gudivada is here. I welcome you heartily, sir, again here in to be with us, and I'm also eager to listen to you. And though I don't belong to your fraternity, I have always enjoyed your lectures during our conference or during your webinars. Thank you so much. I'm very happy.
My pleasure. Thank you.
Congratulations to our Department of Computers for organizing very interesting webinars, and I take pride in declaring Computer Department to be the leader amongst all to organize new activities, and Dr. Archana is enthusiastic organizing everything with all her energies, and she has got a very good team in her faculty, like Rahul Singh is there, like Junaid is there. Okay, senior faculty members are also there who keep doing some or other thing all the time, and computer department is an activity hub. Madam Patil is there to take care of ERP things. Madam Shastri is there to inspire the like students with new things, and they help our HOD, okay, who is really after the new things, the latest concepts to be communicated to the students, keep them at maximum potential, and they are doing very good. Like we have got many students who are really good, like they are doing very good in corporate and have like built up their image, and hence the image of institution very big. I look forward for more of such students coming from your department, and giving you all again the new credits, new feathers in your cap. Thank you.
Thank you, madam. Thank you, madam.
Thanks.
Samruddhi, over to you.
Thank you, ma'am. And here comes our favorite speaker, Dr. Venkat N. Gudivada, sir. Sir, your last session was really wonderful, but I should instead express these feelings opting the language which has a shortcut to your heart. Me last session, Chala Bagunadi. I hope my pronunciation was correct, but when we... Thank you, sir. But sir, when we completed our webinar series, we realized that in the whole dish of webinar series, a pinch of salt was missing, and that was because of your session being postponed. We are sure that this gap will be filled by your session, and our dish of webinar series will be 10%. With delectation, I take this opportunity to request Dr. Gudivada sir, who is a professor and chair of Computer Science Department at East Carolina University, USA, to begin with his session. Gudivada sir?
Yeah, thank you, Samruddhi. Thank you all for a wonderful introduction. It's always good to see all of you with a smile. That's what we call here service with a smile. And Dr. Latkar, madam, said that education is not just what we learn from textbooks, but we should also carry certain personal values and professional values. So I think you seems to be getting a mix of both. That's the right approach. At the end of the day, we are all humans. We work with humans, and we should never forget about our human nature when we interact with each other. So I think that's good to emphasize that aspect. Personal skills and professional skills, they're quite valuable. Sometimes they're more valuable than technical skills. Okay, so having said that, without losing much time, I'm going to share my screen. Okay, so do you all see my screen?
Yes, sir.
Okay, so last, this morning for you, I sent my slides to Dr. Archana Rajurkar to share with you. Since then, I made a couple of changes, but again, if you are interested, I'll send it to her after this presentation. And also I have some code that some of you are interested in exploring, this code. So when, we thought about, when Dr. Archana Rajurkar proposed a webinar, I gave in a couple of topics, or maybe more than 2 topics. So she liked, wanted to have both. So I was initially planning maybe we should have only 1 topic, but have the seminar spread across the 2 days, so that in the first talk, you provide the background. In the second talk, you can actually build on it. But she said, maybe we should really have 2 different topics. Each topic could be done in 1 hour, 30 minutes, or 1 hour, 20 minutes. So that makes it, it's necessarily going to be providing inspiration, providing resources, and giving you a taste of what this area is, as opposed to becoming an expert, right? So the saying goes, to truly become an expert in any area, it takes 10,000 hours of practice. That may be kind of high end, but certainly it takes much longer than just 1 webinar. Or even taking 1 or 2 courses may not actually be enough. So in fact, when we had some discussion with National Institute of Technology, Karnataka, they were planning a workshop on probabilistic graphical models done by a few experts. And it's almost like, the workshop, the minimum length is about 1 week. So in order for you to learn enough to be able to apply, you need 1 week, or at least, a minimum 1 course, a semester long course, or ideally 2 semesters of coursework in probabilistic graphical models. So I just want to show you, I do have some references. You could actually see if I'm focusing my camera right. So this is the standard in a book. This book came about in 2013. And I have spent, sometimes to read 1 page, I would have spent more than an hour to understand what is in that particular page. So this topic can tend to be quite theoretical as well as very practical. But sometimes to understand some of these topics, it really takes quite a bit of time. But you realize anything that's useful, anything that's interesting, that's exciting in life, you really need to work hard to achieve it, right? Personal growth, professional growth, or even coming up with some good research idea that will have widespread impact. It requires a lot of effort. So some mathematicians work a lifetime to solve a problem, and at the end of the day, it is a life well spent. They solved only 1 problem, but that's a difficult problem. But lots of people benefited, or lots of problems were able to solve other problems using that mathematical result. So with that, the title is Interpretable Machine Learning and Probabilistic Graphical Models. So there are 3 things. One is Dr. Rajurkar already talked about what is machine learning. So we briefly touch upon it, and also we contrast machine learning with AI. Then we're talking about an interpretable machine learning. So why is this adjective qualifier here? So when we say interpretable, what we're talking about is, if your machine learning system comes up with a recommendation, for example, you want to be able to ask the system, explain your reasoning. How did you come up with this, answer, or with this line of reasoning? So the system should be able to say, okay, this is what I have done. For example, you think about a machine learning system for a physician working as a physician's assistant. So a physician will ask, talking to the patient, and the machine learning system is observing this conversation, hearing this in a conversation, and the physician eventually will come up with the diagnosis and come up with the decision. The patient might have this problem given these symptoms. So the machine learning system is also hearing this in a conversation, understanding this, what the patient is saying. It will also come up with its own diagnosis and recommendation. So the physician should be able to ask if the decisions are quite different. Even if the decision is the same, the physician may like to ask the machine learning system, tell me, how did you come up with this conclusion? What are the various steps in your reasoning process? So that's what we mean by interpretable machine learning. And then there are several machine learning algorithms or systems that can explain the decisions. And one of the approaches that we are going to look at is probabilistic graphical models. A lot of people actually may not know probabilistic graphical models because this is an advanced topic in machine learning. A lot of machine learning courses may not really touch upon probabilistic graphical models because there's enough material to be discussed, and usually they don't get to this topic. And it also requires reasonably good background in probabilistic theory. And also in computer science, you have also graph theory. It really combines both probabilistic probability theory with graph theory in computer science. So it requires a little bit of a background to study this area. Okay, so most of you were there last time. I'm not going to say much about East Carolina University. This is our university. And I'm also going to really spend very little time on this. We talked about this in the last webinar. And I really encourage you, if you're not really clicked on these links, these are all clickable links. And these are really very good resources for you to develop yourself in this. I think it's interesting you're calling it COVID holidays. And I think it's the best way to make use of your time. I know we'll all like to chat and talk, but sometimes I think we also need to go inward and be able to focus and develop something new, taking advantage of this COVID disruption, as opposed to worrying about I'm not able to meet my friends, I'm not able to do things that I normally do. So we could take advantage of the web and beautiful resources that are available on the web. So this slide has really beautiful materials for you to develop expertise in some of the areas listed here. And we also talked about in the last webinar resources for professional skills and development. And as Dr. Latkar Madam said, being able to actually other aspects, in addition to technical aspects. For example, being able to express, like Samruddhi, she's a very good orator. She articulates quite well, and she could be a role model for other students as well. Being able to speak in a concise way and be able to speak with confidence. And also, when you write, it's also important to write well. And fortunately, we have tools like Grammarly. There's a free edition of Grammarly available. And if you write any significant piece of writing, even if you write an important email, before you send it to somebody, you really want to check with Grammarly. But after a point, you may develop an expertise that Grammarly may not be able to find many mistakes. But even today, if I'm sending an important email, I like to actually run it through Grammarly. Sometimes it does find one or two things which I'm not able to find, because when you're writing, you're thinking and writing at the same time, and you don't necessarily focus on grammatical correctness. Often you do, but sometimes you do have some mistakes. So there are a few other tools that I have listed. I'm not going to repeat this because we did that in the last class. So this probabilistic graphical models, I just want to say significance of it is in computer science, we have Turing Award. I do not know how many of you are aware of a Turing Award. It's given every year to one or more people. When I say one or more people, maybe it's a team award, and it can be shared by multiple people. So Turing Award is like, is like a Nobel Prize. A Nobel Prize, there's no Nobel Prize for computer science, because when computer science, when Nobel Prizes were awarded or allocated, that time computer science did not exist. So now we have something called a Turing Award, Alan Turing Award in his honor, and every year somebody gets this award. Or it's not required that every year you have to give out this award. If there are no qualified people, you don't give out this award. So it's really very prestigious an award. And in 2011, it was given to University of California, Los Angeles professor. His name is Judah Pearl. And the citation for this is he made fundamental contributions to artificial intelligence through the development of a calculus for probabilistic and causal reasoning. So this is really the topic that we have. Probabilistic graphical models is this body of knowledge. It started in 1980s, And lots of people worked on it. It's the most people who teach artificial intelligence and machine learning, advanced machine learning, they would actually know about this area. So I spent a bit of time. I'm not going to go through this list of things. And whether we like it or not, engineering, computer science, these disciplines very strongly depend on mathematics. We kind of the best use of mathematics comes from engineering and computer science, and of course even physical sciences they use mathematics. So without mathematics, there's no engineering, there's no computer science. So as much as some of us may not like mathematics, but I think mathematics is beautiful. It's often said that the God reveals the secrets of nature through mathematics. Okay, so again, these are interesting reads. It's not like going to be a storybook, that you're going to read it at bedtime, you really need to take a serious interest. Nowadays, you have so many lectures freely available on Coursera. So these are really quite celebrated books that and I find interesting. In fact, you look behind me, I have a bookshelf that has lots of books, and these are the books. Some of the books that I listed here, they are in my book shelf. For example, there's Ian Stewart. He wrote a book in 2013, In Pursuit of the Unknown: 17 Equations That Changed the World. So it's your library may have it, or even if you this book may be available in many bookstores, or if you search hard enough, it may be available on the internet as well. So these are some good references on mathematics. Likewise, these are some good books on machine learning. You have really hundreds and hundreds of books on machine learning, but I would actually say even if you pick one of these books and try to understand them well, you don't need to read hundreds and hundreds of books. So it's very important to read the right books. These books may take a much longer time to it's not a page may require sometimes an hour of study, but if you master one of these books, I think you have a very strong foundation for machine learning. Okay, so I'm not going to look at each one of these in detail. So likewise, probability theory, I listed several books. It's not required that you have to read all of them. You pick any one of them. They provide actually good foundation for probability theory required for probabilistic graphical models. So these are really 7 books I listed for probability statistics. These are really quite good books. If you look at number 7 I listed here, the author made this book freely available on the web. If you wanted to read this book, it's freely available. But you also have a printed version of this book. So many books now are available online. Some are for a fee, some are freely available. So likewise, you have Bayesian methods. This is the Bayesian inference, one aspect of probability statistics. You have frequentist approaches and Bayesian approaches. And these are the 2 good books, and I actually found very well written and also easy to read. So these are good books that you can read. Obviously, many of these books you may have to read it more than one time. So likewise, we have probabilistic graphical models. These are the books that I listed here, and also I have another list of set of books here. And I was referring to the 2011 Turing Award winner, Judah Pearl. He wrote a book in 1988. It's called Probabilistic Reasoning in Intelligent Systems, Networks of Plausible Inference. Also, the book that we used, and I actually taught a course last semester on probabilistic graphical models. And we used this book, is from Kohler, Daphne Kohler and Friedman. These are 2 professors at Stanford University. I think Dr. Kohler, she left the university. She works in industry. She has her own, she founded her own startup in a company. So that's the book, and I was showing you earlier. I can't even lift it with my one hand. And this is actually quite a comprehensive book. It was, I thought it was written in 2009, 2013, but I have it in 2009. I'm not quite sure whether it's a typo or is in fact published in 2009. Yes, it is published in 2009, but I think the first time I came across this book was 2013. That's why I remember this book as 2013 book. So if you are interested in applications of probabilistic graphical models, this is actually quite good book, Sukar's book, Probabilistic Graphical Models, Principles and Applications. And if you really want to know more about this, I would probably start with this book, because he talks about lots of applications for probabilistic graphical models. And then you may get enough interest that let me know the theory behind, and then develop another theory. Okay, so I have several other books listed here for probabilistic graphical models and applications. For example, if you're interested in risk assessment and decision analysis for insurance companies, for example, risk assessment is quite important, so that it will help you to come up with a premium. And this book focuses on that aspect, and risk assessment and decision analysis with Bayesian networks. And if you're interested in probabilistic graphical models and for computer vision, this book, it came out last year, 2019. It's a good book. And decision making under uncertainty theory and applications. So this is also a good book, when you have to deal with a lot of uncertainty, incomplete information, and you want to make strategic decisions, how you could actually do that using making use of probabilistic graphical models. And there's also practical probabilistic programming. This is more from developing systems in a point of view. I know the theory, tell me the nuts and bolts of developing software systems. That's in a good book. Okay, so if you're interested in speech and natural language processing using probabilistic graphical models, so this book, it came in 2015. It's a quite a good book. And we have so many languages in computer science. I just want to ask the audience, did any of you heard the programming language Julia? Okay, so you could respond to the chat box. But this language came in 2012. The reason I'm mentioning this language is it's actually it's really built taking the best of C, C++, Python, Java, and it's exclusively meant for technical computing, so science, engineering applications. And when you write in a code, some of the code looks like math equations. So if you want to translate a math equation into code, if you're doing in a Java, C, C++, an equation may actually be correspond to 5, 10 different statements. Whereas in Julia, it's very interesting that the sum of the code looks like math equations. So it's getting actually quite popular, I would say. And they're also positioning this as the language for data science. Data science, probability, statistics, engineering, computing, technical computing. So it's it's a quite interesting language to look at. There are so many interesting things happening in computer science. It's nice to be in computer science. At the same time, it's also you need to really keep up to date, because there's so many things happening, even within a narrow domain. So many things are happening. So you always need to learn new things so that you could stay relevant, you can stay current. Okay, so one or two words about AI versus machine learning. Often people think AI is in machine learning, but is there a distinction between these two? I would say machine learning is one component, one aspect of artificial intelligence. Artificial intelligence is much more broader. For example, you have computer vision, spoken language recognition, automatic speech recognition, understanding written language, and be able to actually have a computer write essays and articles, and information retrieval, planning, reasoning, learning. All these things come under artificial intelligence. So machine learning is one component that will assist with learning from examples, learning from data. So therefore, when you hear the term, people interchangeably use AI, machine learning, they're not one and the same. Often people, when they're doing machine learning, they say AI. Maybe in some sense it's acceptable, but AI is much broader in scope than machine learning. So what is machine learning? Dr. Archana Rajurkar earlier said, something is said, what machine learning is. And, there are several types of machine learning. We call supervised machine learning as learning from examples. And unsupervised machine learning is really learning without any examples. Maybe you're observing other people and learn intelligent behavior by observing other people. There's also semi-supervised learning, which is really falls in between supervised and unsupervised learning. There's also a reinforcement in a learning you might have heard about. There's a lot of other types of specialized learning within supervised. For example, if you look at supervised machine learning, there are several different approaches to supervised machine learning. So if you just if you want to broadly talk about machine learning, there are approaches based on information based on learning. So if you want specific examples, if you're building in a decision trees using, for example, the ID3 algorithm, this is information-based learning. There's also a major approach in what we call similarity-based learning, and the famous example here is the nearest neighbor algorithm. So, for example, if you want to do classification, you already have certain objects in the multidimensional space. You're given a new instance, and you're also become a point in this multidimensional space, and you try to measure the distance of yourself with each one of the points in the multidimensional space, and whoever you're closest to, your class is going to be the class of that closest points class. And we also have an error-based learning. If you're thinking about neural networks, deep learning, regression, for example, logistic regression, linear regression, support vector machines, these are all based on error-based learning. In other words, you're given an example, you're also told what the outcome should be, and then you can measure the distance in between, the error between what is expected and what is predicted, and you try to reduce this error as you go through multiple iterations. Actually, okay, this is again a typo that I have here. This is not error-based learning. It should be probability-based learning. So probability-based learning, I maybe cut and paste, and I didn't change this one. So probability-based learning is you have naive-based model, Bayesian networks. That's going to be, probabilistic graphical models also come under probability-based learning. But probabilistic graphical models actually are based on probability theory, but it also draws upon graph theory. Okay, so with that, let's move on. Let's say a couple of things about what is interpretable machine learning. So you can think of machine learning models as belonging to one of these two, white box techniques and black box techniques. So neural network, for example, is a black in a box technique, in the sense that, for example, you give an image and it will classify that image to be of certain class. It will, most of the time, let's say it will predict correct in a class, but if you ask a neural network, explain how did you classify this image to belong to this class, it won't be able to explain, at least until recently. So such models are called black box models. It's like you give me some input parameters, I give you my decision, but for you, it's opaque. How I make my decision is not of your concern. So this, you can think of this as something that happens when you go to a medical expert, a physician. You go there, you describe your symptoms, your issues, and the physician is going to actually come up with a decision. Often you don't ask the physician, question the physician's knowledge. How did you make this decision? You simply accept physician is an expert and that person knows on how to diagnose. So that you can think of that as a black box and a model. But some physicians may be interested in explaining why you have this particular ailment. Some people may explain, but for the most part, they just don't have time. They tell you this is, you describe your symptoms, they come up with a diagnosis. On the other hand, if you have white box in a technique, the system is able to explain why and how it came up with the decision. So interpretable machine learning models are those that are transparent. You could actually see how they make that decision, and you could explain, that decision. So that's what we call in here, explain the decisions. So nowadays, this has become very important in an area, because you have bias and fairness issues in machine learning. For example, you apply for a bank loan, and most of the time these are machine learning applications that are deciding whether the loan should be approved or rejected. So if it so happens that only certain segment of the society get a favorable treatment, and other people actually get to subjected to unfavorable treatment. In other words, more people coming from certain segment of the society are able to secure a bank loan, whereas with similar credentials, people coming from a different segment of the society, they were denied. Then there's a problem. There's a fairness issue. There's also a bias issue, and some of the societal problems that we face today are really arising from machine learning algorithms not being fair and being biased. So it's very important that we want machine learning models be able to explain the decisions, and be able to we should be able to see if there's any bias, if there are fairness issues given that interpretation. Okay, so here is a slide that lists some recent papers. Again, these are all clickable links. Interpretable machine learning methods for understanding complex models. I believe this paper came very recently. And also there's an interpretable artificial intelligence. This is the link. This is actually a book that's being written. And there's another book, Interpretable Machine Learning. Here is the link to that book. These are all new books, because this area itself is actually new. Even though people started talking about interpretable machine learning, to the best of my knowledge, going back to 2015, still it's an evolving area. Okay, I thought I had some recent papers. Maybe it's coming up somewhere else. Okay, so what about interpretable machine learning models? For example, if you look at linear regression, logistic regression, generalized linear models, and also generalized additive models. So if you have a model based on these approaches, you could actually explain how you came up with the decision that you came up with. Also, you have decision trees. We have decision rules, and also something called rule fit. These are also machine learning models that you could actually explain how you came up with the decision. And neural networks, I put a question mark. Until now, it's not possible. Now people are trying, even with the neural networks, deep learning models. Can the model explain its decisions? And we're going to focus, for the rest of this, lecture, the webinar, probabilistic graphical models. And you could actually explain the reasoning using probabilistic graphical models. That's one of the attractions of probabilistic graphical models is it is an interpretable machine learning model. Okay, so this is what I was talking about. I thought I missed in this slide. I do have this slide. These are the papers, 2017 paper. This is a 2019 paper. And this one is a 2020 in a paper. And the last but one, this 2018, the building blocks of interpretability. So as I said earlier, we're not going to become experts, but my goal is to provide you right pointers and also create some excitement, why this area is interesting and why you should learn more. So these are all really, I have looked at these papers, and I think it's worth reading these papers to know more about, especially, for example, on the interpretability of artificial neural networks. For example, if I click this slide. So here is the paper. This paper came very recently, 2020. It was actually posted, submitted on 8th January 2020. So you could actually read these papers. They're freely available. So you have PDF only. You could download and read. Okay, so now we are talking about probabilistic graphical models. So this is the topic of our discussion, and we need to keep in mind two things. For rest of this discussion is what are probabilistic graphical models, and what kind of applications can we build using probabilistic graphical models, and what are some of the challenges in probabilistic graphical models. And the fourth component is how can we, we say that they're interpretable machine learning models. So how probabilistic graphical models can explain the decisions. Okay, so let's go through this bullet points one at a time. Probabilistic, in general, any intelligent behavior, if you think about humans as intelligent human beings, we are able to actually deal with uncertainty. We're able to actually live with incomplete data and be able to connect the missing dots and make sense out of it, right? That's one of the good, the great characteristics of humans is we could deal with the uncertainty, we could deal with incomplete information. So probabilistic graphical models, we could quantify uncertainty. We can also explain reasoning using probabilistic, probability theory. So that's the number one aspect of probabilistic graphical models is you could quantify uncertainty, you could reason with uncertainty, and also explain your decisions given the uncertainty that you have to deal with. We could also address the question of causality. Okay, so this is a $1 billion question or even a $1 trillion question that what causes what. Correlation in statistics probability, they keep saying, emphasizing, any book I have seen, they say that, correlation does not imply, causality. So what causes what? So probabilistic graphical models is a starting point towards addressing the question of causality. I have observed this event. Tell me what other events caused this particular event. It draws on ideas from probability theory as well as graph theory. Nice thing about it is it has very strong theoretical foundation, yet it also has powerful applications, right? So we keep at least for me, I keep saying to my students, to myself, that a theory without applications is useless. On the other hand, an application without a theory is blind because you do not know what the limitations of these applications are. So it's a good situation to be in where you have very strong elegant theory and also you have powerful applications. This is really a good combination, right? A useful theory based on which you could build lots of powerful or useful applications. So the central idea for probabilistic graphical models is we are going to model the complexity of real-world applications using joint probability distributions. So I'm not going to go into all the nitty-gritty details and the theory behind. I do not know. I believe most of engineering students and computer science students at MGM, you take a course in probability and statistics. I assume so at least one course. So you heard about probability distributions, and you heard the terms like marginal distribution, conditional distribution, joint distribution. But we'll try to keep it simple yet provide a conceptual understanding. So it's basically modeling the complexity of real world using joint probability distributions. It also allows us to combine prior knowledge with observed evidence. And then, in other words, this is the prior knowledge. For example, you may say in a particular state, 70% of the population is prone to certain type of disease. And in some other part of the world, the same disease occurrence is a lot less. Only 10% of the population has this disease. Or it could also be tied to race. In some races, in human race, hypertension or the blood pressure is high. For some other segment of the population, blood pressure is not as prevalent. So that's our prior knowledge. We could incorporate in that prior knowledge into probabilistic graphical models. And we could also, you might have observed an evidence, for example, some event occurred. So given this prior knowledge, given that I have observed this event, then you could also ask questions, under this scenario, what if questions? I have observed this evidence, and if this is my prior knowledge, I can change my prior knowledge, and then I could also change my observed evidence and still ask a question. So it provides a very interactive platform where you could engage in what if scenario questions, and the system should be able to tell you exactly why this decision is made and how that decision is made. Okay, so what are some of the applications? So optical character recognition, OCR. So some of the professors may recognize this has been a problem. Optical character recognition has been a problem that was being solved long time ago. But I think actually it's solved for English language. It's not solved for many languages in the world. And also, even if you think about cursive writing in the English language, optical character recognition is not solved in a problem. It's still an open problem. So I'll just show you, one quick example. It's a beautiful example somebody came up with. Beautiful application somebody came up with. So there's a company called MathJax, actually it's MathPix, THPIX. So they have an application that you could install. Okay, so it's available even for mobile devices. So I have that application installed on my computer. So what I will do is it will enable me, for example, here is an equation. I wanted to recognize this equation. So what it does is it actually comes up with LaTeX code. If you can see my screen, I think it's not moving. I can move this one here. It went away. But what it is it actually recognized that equation and came up with LaTeX code. So this is the LaTeX code that if I compile this, I will get this equation, exact equation. So it's a very interesting application of optical character recognition. You not only recognize characters, in this particular instance, it's able to encode the recognized characters using LaTeX markup, and you could compile that to get this exactly this equation. Of course, this MathPix, it could also do character recognition. For example, if I do this character recognition, okay, so this one, it actually came up, it did recognize when the variables are not independent. Of course, this was not really a difficult problem for this particular recognition, because I had a clear font. There's no background noise. There's no tilt. But even if you have all those, it does in a good job. And also it assigns a degree of certainty. For example, okay, I did recognize this text, and confidence, okay, here is 0 is the left-hand side, 100% is the right-hand side. So this is also based on probabilistic reasoning. You come up with a decision, you assign a degree of confidence in that decision. So that's a beautiful application for optical character recognition. Okay, so I just want to sidestep for a few seconds here. When I think about an optical character recognition, I try to encourage my students to work on this problem, especially those coming from India. They know their mother tongue, and why don't you solve this problem for your mother tongue? So some of you, if your undergrad students are they could be coming from engineering, they can be coming from computer science. If you really are interested in working on this optical character recognition for Marathi, I don't speak, but I think you will be the domain expert. It will be really a great service to your mother tongue to provide something like MathPix. Somebody wrote a note in Marathi, you wanted to quickly get that into machine readable Unicode format. So that will be a good research problem to work on. And not only intellectual excitement, but when you graduate, this would be a good thing to go on your resume, that I solved its optical recognition, optical character recognition problem using probabilistic graphical models for a Marathi language. Thousands, I would say even millions of people are working on English language. And if you don't work on your language, nobody else is going to work on that language. So I'm really very fond of really promoting all languages in India. whatever those languages are, because those are such such rich heritage. That's something that's unique to that part of India that people should preserve and help more and more people speak mother tongue. Okay, that's optical character recognition. You can also use it for image denoising. Your image has additive noise or multiplicative noise, and you could use optical PGM techniques to remove noise from images. And more importantly, you could also use image segmentation. You could use probabilistic graphical models for image segmentation. Incidentally, Dr. Rajeshkar's, one of her PhD students is exploring using probabilistic graphical models for segmenting images, biomedical images. We could also use it for RNA. This is the biology in the life science and application. You have DNA, you have RNA. So you could use PGMs for RNA structure prediction. And this takes us to syntactic analysis of written sentences. For example, syntactic analysis is for each word in a sentence, you wanted to assign a part of a speech tag. So you could use PGM models to do syntactic analysis, even parsing of natural language sentences. Lastly, we could use PGMs for automatic speech recognition. PGMs also have been used for decision making under uncertainty. There are really lots of applications. I just listed only 5 applications on this slide. Okay, so we have been talking so much, but let's get into some details in the next 30 minutes. Okay, so we're going to talk about PGM's challenges and probability in high dimensions. Okay, so now what we have here is we have 2 random variables, x1 and x2. These are 2 random variables. And these random variables are binary random variables. They take the value 0 or 1. Then based on these 2 binary random variables, we wanted to predict y. So y is also a random variable because it's actually a function of 2 other random variables. So in other words, x1 will randomly assume a value 0 or 1. x2 will also assume a value 0 or 1. And you wanted to predict the value for y based on, given the values for x1 and x2, you want to predict the value for y. So remember, y is also binary random variable. Actually, you're predicting a binary variable. I can't highlight only this. So y can take either value 0 or y can take value 1. So think of this as predicting spam emails. You have an email. The email has a certain number of words. In this case, now we assume we have only 2 words in the email. And those, x1 is a word, x2 is another word. And if the email has that particular word present, it gets a value 1. If in that email, if the word, x1 word doesn't appear, it gets a value 0. So likewise, now we have another word. In that email, it is present or it's absent. If it's present, the value is 1. If it's absent, the value is 0. So y can actually take either value 0 or 1. So when y takes a value 0, means what it means is, yes, it is not a spam email. If y takes a value 1, means it is a spam email. So what are the last column? These are the probabilities that are associated. So if the random variable x1 takes the value 0, x2 takes the value 0, the email message is not spam, that probability is 0.125. So what about the second row? This row says, if the first word is absent in the email and the second word is present, and it is with probability 0.115, the email is not spam. It's a legitimate email. So likewise, we could interpret this. For example, this one, the first word is present in the email, the second word is absent, and the email is a spam, and that probability is 0.135. So I was actually making these slides last night. I just came up with these numbers, but actually these numbers are not going to be this way. You will have a distribution more realistic based on the underlying data. So, but what in probabilistic graphical models, really the problem we are trying to solve is just this table. So this is a joint distribution of two random variables, x1 and x2. Actually, you could think of, yes, it's really a joint distribution of three random variables. In the problem context, x1 and x2 are the input variables and y is the prediction. Okay, whether it's email is spam or not. So what we are trying to do is we're trying to learn these probabilities. We're trying to learn this in the last column, these probabilities based on the data. So the more data we have more confidence in the in the probability that we have learned. So what you see in the last column, this is actually called the parameters of the model. Okay, so these are the parameters of the model. So we're going to, when we build a PGM model, our goal is to learn what you see in the last column, the right-hand side in a column, rightmost in a column. So how many parameters this model has? It has, like what, we have 8 parameters, right? This model has 8 parameters. Okay, let's say, for example, you have, right now we have 3 random variables, and the joint distribution table has 2 to the power 3 parameters. Okay, let's say, for example, if you really want to talk about email, the email may have, you need to really consider lots and lots of words, right? Because English language, let's say, for example, even if you consider 500,000 words can potentially occur in an email. And if you want to build this joint probability distribution table, and the number of rows you will have is going to be 2 to the power, 500,000, 500,000, right? 500,000. So, okay, what is the problem? If I have this many rows, my model will have this many parameters, and I don't even say how big this number is. 2 to the power, even if you think about 2 to the power 50, 2 to the power 100, it's a mind-boggling number. Let's not even think about 2 to the power 500,000. So okay, you might ask, okay, what is the big deal? The problem here is the number of parameters in your model, you'll have this many parameters, and you need to estimate these probabilities. That means you need to learn these parameters from your data. Okay, no matter what, nobody will have, I should have prepared a little more. If you count the number of atoms in the universe, this number may be, much more than the number of atoms in the universe. And I'm just saying with myself, I'm not uncertain how many atoms are there in the universe, but this is really quite, unimaginably large number. It could be, a lot more than number of, atoms in the universe. So, if I have this many English words that can possibly occur in an email, my classification task, whether the email is spam or not spam, requires learning this many parameters. It's almost impossible. You won't have learning data to learn this many parameters. So the brute force approach of learning a joint probability distribution, if the number of variables is 50 or 100, is almost impossible, right? Because 50 variables is quite common. If you look at, for example, medical diagnosis, or even other problems, or classification problems, you will have easily 50 features that you use in classification. So 50 is not an unreasonable number, but if you're going to use the joint probability distribution to answer queries, that's not feasible. Okay, so I spent a little bit of time on this slide. I think it's worthwhile spending that slide. So I'm going to talk about a simple example. And what is a probabilistic graphical model before we go into the details of how it is done. So here is a simple probabilistic graphical models. And again, I'm keeping showing this in the book. This model is kind of widely used throughout, it's actually used throughout the book. It's a very simple university model. So what we have here is we have students in a university. So I stands for intelligence of a student. Okay, now like at MGM, let's say you have, maybe, I'm just assuming 4,000 students, or maybe 2,000 students. And if you randomly choose one student what is the intelligence level of another student. So you may say, okay, intelligence level is in a low, in a medium, let's say high, for example. And what we wanted to do, so you can think of intelligence as a random variable. So you could encode in a low as a 1, medium as in a 2, high as in a 3. So, intelligence is a random variable. If you pick a student randomly at MGM, you wanted to predict what is the probability that students' intelligence is low, or what is the probability that students' intelligence is in a medium, what is the probability that students' intelligence is in a high. Okay, so that's an intelligence in a dimension. It's a random variable. Likewise, they're taking courses. Students are enrolled in courses. Some courses are in the difficulty level in a course is in a low, and in some courses, the difficulty level may be high. So if you randomly choose a course at MGM, what is the difficulty level of that course? So you may just say 30% of the courses are low difficulty. Let's say 70% of the courses are high difficulty. So anyway, this is if you randomly pick a course, there's a 30% probability the course in a difficulty is low, 70% probability the course difficulty is quite high. Okay, that's these are prior knowledge, for example. Then you wanted to predict what grade, for example, we use the letter grades A, B, C, D, A, B, C, D, F. We also use incomplete for I for incomplete. So what you want to predict in the grade the student would make. So what does the grade depend on? The grade depends on the intelligence of the student and the difficulty of the course. So therefore, grade dependent on intelligence and difficulty of the course. So therefore, we have these directed arrows saying that the difficulty of a course, intelligence of a student influences the grade the student will earn in a course. And let's say, for example, before you get admitted, here we use something called in high school, students take what is called an SAT or ACT exam. So one of the admission decisions is based on score students have on this standardized test. So S stands for, let's say, SAT exam. So the score that a student earns on an SAT exam is influenced by intelligence level of the student. So let's say, okay, you're done with courses. Now you graduated, you're applying for a job, your company is asking, or the potential employer is asking for a reference letter. So you go and ask a professor, okay, I want a reference letter. I took your course, please provide me a reference letter. So the quality of the reference letter could also be, you could have low, medium, high. So what I mean by medium, low, high is the professor, is lukewarm. Yeah, I know the student is good. You don't really praise the student. Medium is, yeah, student is very dedicated, reliable, dependable, produces good quality work. High is, you rarely come across students of this kind. That person is a self-starter, has a lot of drive, get work done on time, produces high quality work, whatever, that could be a high quality letter. So the quality of the letter the student gets from the professor depends on the grade. Okay, actually it should be much more than grade, but maybe depends on how many students you deal with. If you're dealing with hundreds and hundreds of students each semester, sometimes student comes by your office, you may not know the student's name because you have forgotten it was 2 semesters ago the student took your course. So basically many professors will look at the student transcript unless they personally know the student, and they try to write the letter based on the grade that the student has earned in those courses. So this is a very simple probabilistic graphical model. And why do we call it interpretable machine learning model? Suppose a student got the letter quality, the recommendation letter quality is very high. You will be able to explain using this probabilistic graphical network why the student got a very high quality letter of recommendation. Okay, you could actually use this graphical model to explain that. You can also say, for example, given the student intelligence is, let's say, for example, medium, and the course difficulty is, let's say, high, and the student made an A grade, the highest grade, for example, in that course, and also you could also do that for other courses. What is the probability that the student will get a letter of recommendation that has medium quality? So you could actually predict in a given evidence of intelligence of the student and the degree of difficulty of a course. You could predict grade. And given all these three, you could also predict the quality of the letter the student would receive. Okay, I'm just trying to conceptually say, this is the beauty of probabilistic graphical models. Once you build this model, you can think of this as a causal network, very loosely, but somebody would actually find fault with me to say that. But you could roughly think of this as a causal network. In other words, a good grade, the parameters that influence a good grade is the difficulty of a course and the intelligence of a student. Okay, so that's essentially at a very high level what a probabilistic graphical model is. Okay, so I know this is a little bit of math in this, but I will try to go through this very quickly. Let's say, for example, you have n number of random variables. Usually we use the uppercase x for random variable, and if let's say if you have x sub 1, this is a random variable. If this random variable assumes a specific value, we indicate that value in lowercase x1. So here we have n number of random variables, x sub 1, x sub 2, all the way to x sub n. What is the probability of observing this particular value for the first random variable, and this particular value for the second random variable, and this particular value for the nth random variable? If you know that these random variables are independent of each other, then the joint distribution is simply a product of their marginal distributions. Right? So this is really a beautiful situation to be in. In other words, none of these random variables depend on each other. If that is the case, the joint distribution is simply a product of these marginal distributions. If you go back to the previous slide, that's not necessarily the case. The SAT score depends on the intelligence of the student. That means there is dependency, right? There's an influence, and intelligence of a student influences the score the student will earn on the standardized test. So these are not independent of each other. So likewise, grade is a random variable. It is not independent of D. Grade is also not independent of I. So it may be possible once you observe a grade in a particular grade, then letter is not dependent on the degree of difficulty of a course. It's not dependent on the degree of intelligence of a student. If you already know the grade in a course, then it doesn't really matter what these values are, because this has been observed. You have evidence for this course. In that case, the independence or the dependence is only here, and D and I, they're independent as far as an L is concerned. So having observed a value for G, you could say that D and L are independent of each other. I and L are also independent of each other. So this independence concept is important to break, to actually manage or to work with the joint probability distributions. So if the variables are not independent, for example, then what happens? If the variables are not independent, the joint distribution of n random variables is simply, this is a really chain rule. In probability, we have the chain rule. It says the probability of observing, probability of the random variable x1 taking this small x1, the specific value, times probability of the second random variable taking this value, given that the first random variable has taken this value. So this is actually a conditional probability. You can keep doing that and say, what is the probability of the nth random variable taking this particular value, given you have observed these values for the previous random variables, all the previous random variables. So this is the situation that you will deal with in reality. Okay, this is wishful thinking, but this is not happening. So, but this is also very difficult, because if you have 50 random variables, for example, the 50th random variable is conditioned on the remaining 49 random variables. To estimate these probabilities, you need lots and lots of training data. So this also doesn't help. So what we are going to do is, in a Bayesian network, we are going to make some simplifying assumptions. So the simplifying assumptions are given by this equation. It says the probability of observing a specific value for the ith random variable, given you have observed all these values for the previous I-1 random variables, is approximated by probability of x sub I conditioned on only the ancestors. So if you say x sub a sub I, means these are the ancestors of vertex or the node I. Okay, so I need to go back to the previous slide. For example, if I wanted to say what is the probability of a grade given, I needed to include only a specific, actually is conditioned on, I could actually say, let me just write it more generically. So what is the probability of a grade, assuming A, B, C, whatever those individual values are, and you need to condition only on D and I, because you know that the grade depends only on D and I. So the grade is independent of S, the grade is independent of L. So I could say, okay, if I wanted to estimate this conditional probability PF in a G, conditioned on only its ancestors, so the G depends only on its ancestors. So that will give me some relief in the sense that if I wanted to estimate these probabilities, I need to consider only the ancestors, immediate, direct, immediate ancestors. So that's a kind of critical idea to make this problem tractable. Otherwise, it's an intractable problem. Okay, so that leads us to what we call conditional probability distributions. For each node in your graphical model, you're going to compute conditional probability distributions. This conditional probability distribution is conditioned only on the ancestors of a node. So for those who are mathematically, algorithmically inclined, so we have, for example, x1, x2 here, and we have x3. It depends on x1 and x2. These are two random variables. Let's say you have some more ancestors, some more parents here. So here what we have is we have x number of ancestors, and each one of these ancestors can take d values. What I mean by that is, if you look at an intelligence level of a student, it can take 3 values. Let's say low, medium, high. So that's what we mean by this particular random variable can take any one of these 3 values. So if you assume that we have k ancestors for a particular random variable, each one of these k ancestors can take d different values. So therefore, the number of entries in the probability, in a conditional probability table, so this will be row 1, row 2, row 3, row 4. The number of rows in this table is going to be of the order d to the power k plus 1. Okay, why is it so important? If you don't have this conditional probability distributions, then we would have a situation where you will have d to the power k plus 1. Actually, no, I'm sorry. That would actually be this would actually be this would actually be order d to the power of n. Okay, d to each can take d values, and we have n number of random variables in the system. Whereas in this case, we are considering only k number of random variables. Therefore, the number of rows in a conditional probability distribution table will be order d to the power k plus 1. If you don't have this simplifying assumption, then you would have order d to the power of n. So it just simply, you won't be able to solve this problem if you have each conditional probability conditional probability distribution attached to each node will have this many rows, then estimating these parameters will become really difficult. Okay, so in this case, each node will have d to the power k plus 1 rows, and we have n random variables. The total number of rows we need to estimate is n times d to the power k plus 1. So this is much more manageable than the brute force approach. So this is a little bit dense in a slide, but what we're trying to say is it is really based on a simplifying assumption to make the problem more interesting. I would say interesting from a computational perspective. Otherwise, yes, if it takes 2 years to solve this problem, we won't care. We won't wait 2 years for estimating the model parameters. Okay, so I'm going to skip this slide in the interest of time. What this one is actually saying is, I can explain using this graphical model here. So many of you heard about naive Bayes. It's a very simple probabilistic, actually classification algorithm, machine learning algorithm for classification problems. So basically what we have here is we have observed, for example, okay, so I don't know how I got this wrong. This is an x sub 1, x sub 2, x sub 3. This is programmatically generated, so I made a mistake here. So I should have x sub 1 here, and there's an arrow from here to here. So what we have is, think about your email message. Okay, you got an email message. It has, it can have any one of these n number of words. So this n in this case could be 500,000. Like if so most frequently used words in the English language is, let's say, 500,000, or even if you reduce that to even 50,000, for example, people when they write email messages, they may choose any one of these 50,000 words. So each word is a random. So, okay, you got an email message. You ask, okay, here is a particular word. Okay, this particular word, could be "and" is first word. Then you could just say "letter" is in a second word. Maybe "bank" is in a third word. Become rich is in a fourth word. Become is another word, for example. So each one of these is a random variable. So this is the word "and." I should have written it here. This is in a letter. So when you look at your email message, whether your email message has this particular word, yes or no, is a binary random variable. So x1 will take a value 1 or 0. So likewise, you look at the second word in your email message, that's a letter. You can ask, is it present or not? If it's present, this random variable will get a value 1. If it's absent, it will get a value 0. So likewise, each one of these letters, each one of these words, they're either present in the email message or they're not present in the email message. So what this naive Bayes, this particular model says is, you wanted to do a classification. Okay, it is a spam email. Okay, it's a spam email. In that case, the y equal to 1. You just say it is not spam. In that case, y equal to 0. So this is a classification problem, binary classification problem. So what naive Bayes spam classification model, you can think of this as a probabilistic graphical model where you have strong independence assumptions. So what the strong independence assumption says is strong in a conditional independence. For example, knowing a particular email message is a spam, in that case y equal to 1, or not spam, y equal to 0, does not influence whether this particular word appears or not appears. Okay, I'm not saying it, maybe I need to say it a little bit differently. So for example, knowing x sub 1 occurred in this email message, yes, and it appeared, its value is 1, and that a spam, it is actually a spam message. This information does not help to predict this value. The values that these random variables assume, they're independent of each other. So knowing that this class, knowing the class of the email message, also knowing the values of other random variables, it doesn't help. They're independent of each other. In other words, knowing the value for this random variable, knowing the value for this class it doesn't help to predict the value, what this random variable will take. In other words, whatever information that you had in it before, the difficulty you had in it before to predict a value did not change even after knowing whether the email message is spam or it is not in a spam. So that's, you make this in a conditional assumption, then beautifully what you're doing here is this joint in a distribution magically become a product of conditional distributions. So here is the first marginal, actually the marginal distribution. You can say, if you ask in a Yahoo or in a Google email, they may say an average, you can just say, like 60% of the messages are spam, 40% messages are not in a spam. So P of Y refers to, if you just say P of Y equal to 1, this is 0.6, and P of Y equal to 0 is 0.4. So you could estimate on these probabilities. So that's, there's the marginal probability. What is the probability of a given randomly chosen email message being a spam or not in a spam times, then you have product of these conditional probabilities. So the look at these conditional probabilities. What these conditional probabilities say is, what is the probability that a particular word, let's say and, in a given, you can just say Y equal to 1. So in other words, what is the probability of the word and appears in a spam email message? So you could estimate on these probabilities. Likewise, we also can easily estimate, looking at the training data, what is the probability of and appearing, not appearing, actually appearing in an email message where the email message is not in a spam. So you could actually easily estimate these probabilities. I could do that for each one of these words in the email, in the vocabulary that I have. So therefore, I could estimate the joint probability simply as estimating the class in a prior probability of a class, and I need to estimate n conditional probabilities. So in this case, your problem has dramatically reduced in computational complexity. The model parameters are simply, you have n plus 1 model parameters. So if your n is 500, for example, then you have 500 plus 1. So this is not bad. So that's an IU based. It's a very simple one. It's the simplest probabilistic graphical model. And even if n is quite high, the number of parameters in the model is only 500 plus 1. Contrast this with 2 to the power 500. These are really not comparable at all. Okay, so that's a simple example. Okay, so we're almost there. I think I have probably, Dr. Archana said I could go up to, I'll try to finish it the next 15 minutes, and then we'll have 15 minutes for questions and answers. Okay, so yeah, I'm actually almost there towards the end. So if you want to study probabilistic graphical models, what are the various aspects of a probabilistic graphical model? One is in a representation. So representation is, I'm going to go back, and here is the diagram that we talked about. I need to represent my model. Is it a directed graphical model? In this case, Bayesian network is a directed graphical model because each edge in the graph is directed. So you need to decide how many vertices do I have. You also need to decide how many edges are there and which vertices are connected by this directed edge. So this is really what we call DAG, directed acyclic in a graph. They don't have any cycles in this graph. Also, you need to, you will have a what we call conditional probability distributions table, CPD, associated with each one of these vertices. CPD here, we have a CPD here. We also have CPD here. So this is my representation. Okay, how many nodes do I have in my graphical model? What are the edges and which vertices are connected by these edges? That's in a representation. So how do I know in a domain, how do I know this? Okay, so that's a representation aspect. How to specify a model. So it could be Bayesian network, in which case it's a directed graph. If it's Markov random fields, MRF, it is an undirected graphical model. So the next aspect of it is inference. Okay, once I build the model, I want to ask questions. I want to ask questions. So inference deals with asking the model questions. So there are various types of algorithms available for answering questions. One class of algorithms are called variable elimination algorithms. There's also belief propagation algorithms and map inference. We talk about map and variable elimination shortly. Then we also have sampling-based inference, this approximate inference. And we also have another approximate inference based on variational inference. So we have various approaches to answer questions. Once you build the model, you could ask interesting questions. So the third aspect is learning. Okay, so I just highlighted so many things I should have not. So learning. So there are two aspects to learning. One is once I build the model, I have certain number of parameters. I need to learn values and I need to learn values for those parameters. Otherwise, you won't be able to do inference on the model without values for the parameters. So there are two aspects to learning. One is you can learn parameters. Okay, I have built the model. I need to keep going back and forth. I have built the model. I don't know the parameters for this model. So you can learn the values for this parameters for the model. Like you can learn all the CPDs for each one of these nodes. The second one is I should have stayed here. I don't have any knowledge about the domain. I don't know, how many nodes do you have? I don't even know the names of these nodes, let alone which nodes are connected to which other nodes. So I would like the system. Here is my data. You learn from the data, construct the structure itself for me, the model itself for me. You decide how many nodes should be there, which nodes are connected to which other nodes. You learn the parameters for that model. That could also be done. Okay, again, they have limitations on how well you could learn the structure of the model, as well as you can learning the parameters for the model. Okay, so this book I was talking about, it actually talks about learning both the parameters and also learning the structure itself. There are very interesting algorithms for that. Okay, so I'm just going to talk about just two, marginal inference and map inference. So what is a marginal inference? So the marginal inference says, what is the probability of a given random variable? For example, I have random variable x1. I have a random variable x1. What is the probability of this random variable takes this particular value? So in order to do that, what we are going to do is, we have n number of random variables in the system. We're going to systematically eliminate one random variable at a time. So for example, we're going to sum out the nth random variable from the joint distribution. Then we have only n minus 1. Actually, I would say this is one random variable here. I have n minus 1 random variables here. So once I sum out x sub n, then I have n minus 2 random variables. Then if I sum out the next one, I'll have n minus 3 random variables. Then I would actually have no random variables. You're systematically summing out, eliminating one random variable at a time from this joint distribution. This joint distribution. So then what is left is what is the probability of x1, the first random variable, assuming a specific value. So these type of questions are called marginal inference. And you could do marginal inference for any one of these variables, or a combination of these variables, and you could do marginal inference. The second type of inference is what we call maximum a posteriori map inference. So the map inference deals with what is the most likely assignment of variables. Okay, so for example, if you have our mail example, so your email may consist of a subset of this x sub n number of random words. We consider these words as random variables. They either appear in the email or they do not appear in the email. So the map query is asking, what is the most likely assignment of values for the random variable x1, x2, xn, together, not individually, But simultaneously, what are the most likely values for random variables x1, x2, x sub n? To make it more concrete, you ask, in a typical spam email message, what would be the value for x1? Would that word appear or not appear? Would the second word appear or not appear? So you have two classes, right? You have a spam and you have not a spam. So given a specific value here, if it's a spam email message, what is the most likely assignment for these random variables? In other words, you can say in a spam email message, these words must be there. In a non-spam email message, these words most likely they are there. So you're always talking about in a probabilistic sense, okay, 90% probability this word will be there. So that's what we call a maximum a posteriori inference. Okay, so you may say that I showed you a book. I think it's about 1,300 pages or so. Yes, it's about 1,250 pages. I won't have time to read on this 1,250 pages. If you want to spend about a week time and to get acquainted with probabilistic graphical models. So this is a good site. This is developed by a professor and some students at Stanford University. It's a very concise course on probabilistic graphical models. So if you spend a 1 week time, you could actually get pretty much a conceptual understanding of what a probabilistic graphical model is. And this okay, so it should work. They also developed some tools, because this is very abstract. When I say this is very abstract, it's still working. Probabilistic graphical models, you might have figured out by now, okay, yes, we talked about things, but I don't really get it, or I don't see how it works. So these students at Stanford University, they have also developed a website. For example, you have a D-separation algorithm. So D-separation algorithm means, given two nodes in the network, tell me if they're independent of each other. So that's what D-separation is. So you could actually create a node, you could create edges between nodes, and then you can select two words, two nodes, and ask, are they independent of each other? So this is a very good exercise. Likewise, they have an exercise for variable elimination algorithm. So you could create a probabilistic graphical model, and you could you could ask marginal inference for any one of those variables, or a combination of those variables. So this is a very interactive exercise that would they go together. So this would be a good resource. I would really strongly encourage, and if you have 1 week at a time, you may not, I caution you, you're not going to understand everything. You need a teacher, you need somebody else to help you. But at least reading it in one time will help you to get some foundational ideas. That's why you need to work with an expert who had more experience. And then once you implement a system, an application, then you would actually understand these models quite well. So what are the resources available, right? You need libraries, software libraries, or even complete application frameworks. So here is libbin.dai. So if you're interested in C++, this is this is a library for discrete approximate inference in graphical models. There's OpenGM, okay, this is actually Open Graphical Models. Is a C++ template library for factor graph models. Okay, here is the website. And this is the Judah Pearl. I talked about a professor who got Alan Award, Turing Award, Alan Turing Award in 2011. So he started this very early on. It's a Java-based application. You could design probabilistic graphical networks. Okay, now why it's not taking me there? Okay, I'll see why you should actually, maybe it's already took me there. I need to. Okay, anyway, it didn't take me there. So I'll check, this link seems to be not working. I'll figure this out, why this link is not working. So this is SAM, IAM. It's a kind of interesting acronym, SAM, IAM. You could actually build probabilistic graphical models. I had built one using directed, Bayesian network. I didn't build any, Markov random models. Maybe it also allows you to build Markov random models as well, but certainly it supports Bayesian networks, directed graphical models. So they have tutorials on the web. If you go to this site, they have tutorials, they have sample models they have built. You could explore, do types of inference. And some more here, we have BaseNet in a toolbox. If you're familiar with the MATLAB, you want to work in a MATLAB environment, this is the one. If you're familiar with Python, there's something called PGMPY. It's a Python library for building graphical models. Then some more here, you have PyMC3. This is also another library for building Python-based probabilistic graphical models. So then here is, okay, so for some reason it's not allowing me to go. I have a license actually for this. Okay, here is in a Huggin. It's a very expensive piece of software. For education, they have a discounted one. Even with the discount, a license and a cost something like US dollars, something like 1,200. But they also have something called Huggin Lite. Huggin Lite is a free version. It has some limits on how many nodes you could create, how many edges you can create. But for learning purposes, that Huggin Lite will be quite useful. Okay, so I'll correct this link in a problem before I send these slides to Dr. Rajurkar. Okay, so Huggin Expert, as I said, I did install on my Huggin Lite actually. Yeah, okay, it should actually be LITE Lite version. Okay, so I was going to actually walk through some examples. Maybe I could just spend a minute or maybe 2-3 minutes to walk you through at least one example. And let's see what that example is. Okay, so this is a project that was done by one of, I told you that I taught a class last semester, and it was a team project. 2 students got together, Jennifer and Sarah. They created this, this created project. So their goal, for this project is, okay, so the aim of this project is, okay, I need to make it a little bit bigger. So I know Dr. Latkar and other people, they were interested in, even Dr. Archana, with medical image processing. Okay, let's see if we could move this away. Okay, so the aim of this project is to create a model to be able to predict the heart disease probability of a patient. Okay, so our goal is to construct an optimal model. So they go on to talk about a few things, but I wanted to show you, they had some data. They want to build a Bayesian model for predicting heart disease. So they found data on the web. As this is just a sample of data. They showed only the first and a few data items. So here is the age of a person. This is the gender, and CP is some variable. Test BPS. I think rest. Blood pressure. This is the cholesterol. They have various variables. We don't need to spend time, but they do have data, and also they do have target will have a value 1 or 0. Value 1 means the person will have heart disease. If value is 0, is a person is less likely to have a heart disease. So they describe these features here: age in years, gender. For male it's 1, female is 0. CP is chest pain type. Then T rest BPS is resting blood pressure. They have 14, actually 13 predictor variables, and the target variable is the variable that you're trying to predict. Will the person have disease or not? if the prediction value is 1, yes, the person will have disease. 0 means the person has no disease. So, they did some research. They came up with CPDs. These are the conditional probability distribution tables. And for the nodes that have no parents, the CPD simply becomes a marginal distribution. So in the population, for example, if you look at United States population or India population, based on the collected data, you could say that for India population, this is, I don't know which country, men, 68% likely men will have a heart disease, and 32% probability the woman will have a heart disease. In general, that seems to be true in many countries. Men are more likely to suffer from heart disease than women. So what about in age? So we have 3 values for this variable. Age 0, age 1, age 2. So young adults, so only 2% of young adults get heart disease. Middle-aged adults, 48% get heart disease, and older adults, 50% of the older adults are likely to get heart disease. So likewise, here is a conditional probability distribution table. So what this one is this is what is the probability of low cholesterol given the person is, okay, if you look at sex 0, the age, okay, that's a female and young adult. So this value refers to conditional probability. What is the probability of low cholesterol given that the person is a female and the person is an young adult? So that's this value. So likewise, we could say same thing here with respect to cholesterol. What is the probability the person the probability that the person will have high cholesterol given female and a young adult? Okay, so anyway, it's very important that you construct these values. You talk to an expert, or in the discipline you may have some data that's available to estimate these values. Okay, so likewise you have HD, okay, heart disease, low cholesterol, medium cholesterol, and high cholesterol. So they didn't show all the details, but we also have no time to go over all the details. So here is their model. So the model they have built, this is a preliminary model, and cholesterol is influenced by age of the person and gender of the person. Okay, so typically as people get older, their cholesterol levels usually go up. So likewise, gender also different influences in cholesterol. Maybe it's, men may have more cholesterol issues than women. So that is depicted by this relationship. And also we have in a CP. I think we said CP was I forgot about what CP was. Okay, CP was chest pain type. So now you have heart disease is influenced by chest pain type as well as cholesterol level. So obviously it's a very, very simple Bayesian network. It may not produce good results. So then we need to incorporate, they went on to add additional things for the model. So what they did is, yes, the chest pain type alone is not enough. Then they have another factor called an FBS that also plays a role in predicting heart disease. So the final model they constructed is we have age, gender, cholesterol level, chest pain type, then you have blood pressure, and then heart disease. And you notice for each one of these nodes, here is a node in the graphical model. This is the marginal distribution. Because they don't have parents, we call it a marginal distribution. So whereas a node like cholesterol, it has no parents. So then this is what we're talking about as in CPD, conditional probability distribution, is listed for each one of these internal nodes. So likewise, we'll also have CPD for this heart disease. It has actually 1, 2, 3 parents. So its CPD will be a little more elaborate here. CPD for heart disease is this. So now they also computed dependencies, independencies actually. So the various independencies, the various independencies they found is age is independent of chest pain. Chest pain actually, age is independent of chest pain given the blood pressure. So given the blood pressure, chest pain is independent of age, and chest pain can be experienced by any age group. They're independent of each other, given a value for blood pressure. So likewise, you have some independencies, age is independent. This is actually, when you see something like this, she's trying to do, ASCII art. So this is, like you can just say A is independent of B. So this notation that you see here is this independence in a symbol. So they derived on so many independencies. Then they were able to actually do some queries. They did an exact inference. Using an exact inference, for example, variable elimination algorithm is an exact inference algorithm. So they said, okay, what's the probability of blood pressure given normal cholesterol? So the system answered this. So the blood pressure, given normal cholesterol, blood pressure is in a low in 43% of the cases. Blood pressure is in a medium in 39% of the cases, and blood pressure is high in 18% of the cases. Okay, what is the probability of, this is a max, query. Probability of a heart disease actually is given person is young. It's not, it's actually another type of elimination here. So what is the probability of heart disease in a given the person is a young person? So heart disease is absent in 44% of the cases. It is prevalent or present in 55% of the cases. So likewise, they have some other queries. Probability of cholesterol given person is older and blood pressure is very high. So therefore, then you can say, given this evidence, the person is an older person, blood pressure is very high. What is the probability? Probability being low, cholesterol being low, cholesterol being medium, cholesterol being high. So the cholesterol being high, given is 59% given the person is an older person, our blood pressure is very high. So likewise, you could actually ask lots of queries. That is the conclusion of their their study. Actually, they did. Let me cancel. Okay, so they did. Produce. So here is an interactive Python notebook. I was on this computer. Actually, I was not able to. This morning, I thought I could run, but I realized that okay, it should be in another browser. So I realized here is my interactive Python notebook. So this is their work, heart disease in a work. On this particular computer, I don't have all the libraries installed, especially, so it won't run on this particular computer. But if I've installed, for example, these Python libraries, NumPy, Pandas, Matplotlib, Seaborn, scikit-learn, we have logistic regression, train test in a split, it'll run. So I'll, if you're interested, I'll email this as well to Dr. Archana. So if you're interested in replicating this, you could do it on your computer. So I'll send these documents to Dr. Archana. So with that, I think it took much longer than I thought. It's always going to happen this way. And that's another problem with professors. They, given a choice, they like to keep talking and talking, never know when to stop. Okay, so let me see if I could go back. Okay, so should I go back to Samruddhi for questions, answers?
So due to some technical issue, Samruddhi is not with us. There will be Gil sir joining with us. So we will be just checking on the YouTube regarding some questions.
Okay. So where do I think you told me last time.
Yeah. So no questions on YouTube too, sir. No questions on YouTube also.
Okay, no questions. Okay, so you will tell me what the questions are, or they can ask.
No questions.
Okay, they're like, okay. So now they won't be able to ask any questions, or?
Okay, anybody is having any questions, you can ask.
Rahul? I have a question, sir.
Yes, ma'am.
Show the regular
Hello?
screen. Ask her to.
Yeah. Okay. I should have. Okay.
I have
Okay.
a
Go ahead, please. Yeah.
Yeah, these probabilistic model can be useful in deep learning networks.
Actually, if you think of that, you can really view certain types of deep learning as probabilistic networks. Yes. Yeah. Because there it's maybe densely connected network. It just depends on how many hidden layers you have, and which nodes in a particular layer are connected with which layer in the next, which nodes in the next layer. Yes, you could view them as one version of probabilistic graphical models. But again, I think their inference, you may not be able to do the different types of an inferences that you do here.
Sir, I have one question. Can I ask, sir?
Yes, sir.
Go
Yes,
ahead.
sir.
Yeah, go ahead. Yeah.
My question is, what kind of hardware this one suits for implementation of this model?
Okay, so for many practical, if you're looking at a very huge, enterprise level application, so inference, many of these problems are NP hard. So if you know what NP hard is, simplest layman's terms, there's no easy solution. There's no efficient solution for these problems. And if n equal to 40, 50, it can take quite a long time to answer these queries. So for those situations, when you don't need exact inference, you could go for example, in a variational inference, or belief in a propagation algorithms, which will actually they will also do exact inference. But there are other approximate inference algorithms. So you could use a normal computer to be able to solve problems of moderate complexity. But if you're really looking at very huge problems where your graphical model has maybe 500, 300 to 500 nodes and lots of vertices, then you may need a GPU based computer, or a cluster based computer, high performance cluster computer.
Sir, again, one more explanation to that. Don't you think that this model is involving a lot of computations? As I said, that probability density function, if the random variables, they are independent of each other, and since the random variables are large in number, then you said the distribution function is splitted, like probability of x1 into probability of x1 given x2, something like that.
Right. But we try to avoid that. If you really look at the problem, the approach that Bayesian networks do is you have a node here, you have another node here, one more here. So you may actually even have another node here. We make this simplifying assumption that this node, the value this random variable assume is influenced only by its parents. Okay. So therefore, when I say what is the probability of this node saying this value given all other nodes, I think we're saying we don't need all other nodes. We need to consider only the parent nodes. So that would actually help to simplify the construction of CPDs. But it is you have seen in that example that this particular example, if you look at the CPD here, it has 3 parents. This could actually have many columns. I think she kind of did it the other way around. Some people actually show whatever she's shown as rows as columns, columns as rows. That can have many rows. Okay. Yes. Yeah.
Sir, one more question related to that only. Whether we require LTI system or LTV kind of system, if you really want to implement purely in terms of hardware.
Okay, purely in terms of hardware without any software libraries?
Yeah, that is what I wanted to,
Yeah, I do not know whether they have any specialized computers built for probabilistic graphical models. We have a company called NVIDIA.
Yes, sir.
So NVIDIA.
Yeah, NVIDIA. Yeah, their processors are really good. and they support all these kind of these things, operations. But
Right. So
I
they
don't
have
want programming kind of stuff, sir.
right. They have
Programming kind of stuff I don't want.
yeah. So they have some lineup in a computer. So one of them is actually called DGX on Station 1. This is specialized in a computer and only for AI, machine learning. You could also do computer vision and such things.
Yes, sir. Yes,
so this is, I think, this is retail value of this in a computer is about $100,000 dollars, US dollars. But they may be able to give some discount for university. So our department did acquire one of these computers about 2 years ago. So we could explore. This is very specialized in a computer for AI, but I do not know whether they have hardware acceleration for probabilistic graphical models. Very likely that I could find out, and I don't know the answer right now. But one of the things I'm saying to people who are listening, especially the undergrad students, if you are really interested, I could actually get you access to this in a computer, and you could pick some interesting problem. I'm specifically interested in language problems like optical character recognition, for example. Or of course we could also do other problems, but that's I'm very fond of working on optical character recognition. So you don't need to have local access. I can arrange for you to get an account, and if whoever is interested, and work on this type of problems. Yeah. So I'll know. I need to contact the rep for this system that we work with, and see if there's any special support for probabilistic graphical models. They do have lots of support for deep neural networks. But I'm not quite sure. Probabilistic graphical models are kind of a little bit different from deep neural networks, even though you can think of deep neural networks as an instantiation of probabilistic graphical models, directed models. Yeah.
Thank you so much, sir. Sir, one more extension to this question. We have seen example related to binary random variables. I think these kind of random variables, it is a trivial kind of case. If suppose random variables, they are taking n different values, each of the random variables, then complexity will be very large.
Right. Yes.
In this case,
so if you remember, if you remember, one of the things we said was that in that case, the complexity is n is the number of nodes you have the network.
Yeah.
And you have a parent. It has k parents, and each parent can have k values.
Yes.
And this you have to estimate this many parameters.
Yes, sir.
So d, usually if it's a binary, d equal to 2, but some cases they may take 5 values. In that case, this complexity, number of parameters will increase. Yes, but again, you realize in real life, what happens is binary may be too simple, but if you want to, let's say provide 10 different values, it may be one, another extreme. So if you have these 10 different values for a random variable, we need to come up with training data. Right? For each, this random variable takes one of these 10 values, but you need to have examples for each one of those 10 values, and not just one example, many examples for each one of those values. And often, people, would start with, okay, let me, try only maybe, let's say, 3 values and see the performance of the system and how does it compare with an expert in a performance. If this is not satisfactory, maybe I could increase the number of levels for some key nodes to 4. So that's why people we have so many jobs, because we have all these algorithms already implemented, but still these decisions cannot be automatically made. See, in machine learning, for example, if you get a job in machine learning as a machine learning engineer, is less likely you're going to implement any one of these algorithms. You're going to use a library. They're fine-tuned, they're optimized. Yes. But still, we need a lot of people, because the machine learning library doesn't say, how many nodes you should have, or how many. Right.
Yeah. Really, sir. Really, your this talk was really excellent. I enjoyed every slide you presented. Slides were chosen very perfectly, and I enjoyed every slide, sir.
No, really, thank you.
Really, I understood every slide, sir. Yes, sir.
Yeah,
yes, sir. Sir.
Yeah, go ahead. I'm listening.
Yeah, sir. I enjoyed this every slide, and your explanation was superb. And
Thank you
any
so much.
person who is not knowing anything, that person can also understand
Okay.
everything. Whatever you explain in the beautiful fashion using that tree structure and then probability density function, their products and everything. All kind of doubts. Mostly those they are there while learning all these things. You answered all those doubts very nicely, sir.
Thank you.
Thank you so much, sir.
Yeah, I just want to say, one thing. I usually like to use printed or in a good slides, but last semester I was teaching this course for the first time. I didn't have enough time, so I requested my students to forgive me for my handwritten notes. So this is just on inference. For example, this is just on inference, and I have 151 pages of handwritten notes. So I think it's there's a lot of if you look at variable elimination here, we do, in a talk like this, we don't want to go into all these details because people will lose interest.
Yes.
Right. So you just want to present at a conceptual level so that if somebody is interested in, they can go into these details. But if my slides had something like this, I think many students would kind of tune themselves off. Right. So yeah, this is a very interesting area, but I was trying to make it conceptual so that you get people interested to know the details.
Yes, sir.
Okay.
Thank you so much, sir. Sir,
my pleasure.
Can you give me the example for this independent random variables? If we are having n random variables, they are independent of each other. Example for that.
Oh, okay. I think so. You're asking me if I have n number of independent random variables. Can we think of an example? But actually, in reality, what happens is kind of rare to find, independent. For example, I could say, let's say you wanted to predict, like the gender of a newborn child.
Yeah.
I don't know what parameters are used, but even when the conception takes place, if you wanted to say whether it's going to be male or a female, it looks like those you won't be able to predict. It's 50% chance and it will be a female, 50% chances to be a male.
Absolutely, sir. Yeah.
Across population. So whatever variables people use to predict, those variables tend to be, we can assume they're independent of each other.
Yes.
But in reality, it's very difficult to find where everything is independent of everything else. So that's why in probabilistic graphical models, we make a reasonable assumption that independence is there, the dependence is there only from a node to its parents.
Yeah, absolutely.
So that will localize the dependencies, and then the joint probability distribution becomes more manageable. Then it becomes a product of various conditional distribution factors.
Thank you so much, sir. Thank you,
my
sir.
pleasure. Yeah.
There are some questions on chat.
Okay, so I'm trying to get back to my Zoom. So you could see my screen. I lost, okay, where is...
to just unshare.
Okay, unshare. Okay, you're sharing, stop sharing. Okay, yeah, okay, I'm back. Okay. So I go into chat area to see what questions you have.
Stop sharing. Stop. Yeah, stop sharing.
Okay, so what? Okay, so let me go through what are the different scenarios where we require justification of prediction made by model. Actually, if you think about in a computer science in general, people, because of its pervasive nature, we have so much influence on how the society functions, right? You think about social media that's happening in politics. misinformation or disinformation. So when some, like for example, I have a recommender system. It says, okay, here is a news article that's of interest to you. I want to be able to ask, why are you suggesting this news article is of interest to me, right? Same thing with, product recommendations. You go to Amazon or some local in India, you have Flipkart, something similar. If they say I'm recommending this book, we just blindly take, okay, this may be a good book, but you're curious, why are you recommending me this book? So I think society, as we progress in artificial intelligence, machine learning, not only a decision, I also want to know why this decision is made. So I think it's, people are asking, same thing, like I'm denied admission in my admission application to a university. Instead of getting, you have been rejected, I wanted to know, tell me your reasoning why I have been rejected. Okay, people are demanding these kind of answers. So that's where we are evolving. And also in the US, for example, we have racial issues. I think racial issues, they're everywhere, not just United States. So some segments of the society, they receive favorable consideration or favorable treatment. Some other segments of the society, they're treated unfairly. So the question here is, if you wanted to ensure your system is fair, it doesn't have bias, you need to examine why it is making recommendations the way it is making, and you need to study if there is any implicit bias in the system. If so, you need to remove that bias. In the US, for example, recently there's a lot of unrest about African Americans being not fairly treated, and police seem to target them, sample them, or stop them more often than, for example, people like me or, white Americans. So that's unfair because, I may not be affected, but they're also human beings, and we want systems, we are making those systems, or we are educating students who will actually, go into workforce to make, these systems. And we need to be aware of, this social injustice, which is, important, everywhere, even though some of us may not be affected, but we are really at the forefront of creating a equal society, right? Or equitable society. So that's the AI. It need to be able to explain its reasoning for various reasons. Societal reasons is one important aspect. Okay, so second one is combining neural networks with the graphical models possible. I answered this question earlier saying that you could think of deep neural networks with multiple hidden layers is a special case of Bayesian networks. But again, the way neural networks work, if you're using it for classification problem, it's very hard to ask a neural network, tell me how you made this decision, right? People are trying to work towards making neural networks be able to explain those decisions, but that problem just started. People started working on research. It will take a bit of time before we could represent, before we could make neural networks answer their decisions. Okay, what will be the complexity if you represent graphical models in representing any domain problem? I think the complexity is really how many nodes you would identify. For example, I showed one of the examples my students worked on, 2 students as a joint project, predicting heart disease. If you look at their model, they had only 6 or 7 nodes. But in reality, if you want to factor so many things in, you will have maybe 30 to 40 nodes. Right? So it's a question of building a simple model first and trying to understand its behavior and trying to add more nodes. And also you want to make sure you have the data to learn or to come up with CPDs, conditional probability distributions for each one of these nodes. Okay, so I think we also answered from Dr. Manisha Joshi that probabilistic models or algorithms requires large resources. How we can apply them in IoT applications? I think they're really they're not really dependent on any particular domain. IoT, I would say, is a good target in a domain for probabilistic graphical models. For example, a simple problem such as a printer, a network in a printer, if it's not in a working, let's say in a Windows in an environment, troubleshooting a network in a printer is not a simple problem. I think depends on your domain expertise. Some experienced person may be able to troubleshoot in a few minutes, but some people who are just learning, they may take in a few days to troubleshoot. Still, they may not be able to resolve the issue, but you cannot keep a network in a printer not operational for that long. So you could actually build, for example, a probabilistic graphical model. Given evidence means maybe you have certain signals that are blinking, certain signals are you have observed certain evidence. Given this evidence, what is the most likely cause for this network in a printer not work? So such application is a good one. But you could also build with IoT. You have data generated by IoT devices. It's often the devices could generate the data that may have a lot of noise. And probabilistic graphical models are a good way to incorporate uncertainty and noise that's inherent in the data.
Thank you, sir.
Okay.
Yes, sir. I want to know that basically many applications we have the very less resources, and we how we can go all these probabilistic algorithms. They are usually NP hard problems, and so obviously the complexity wise these are vary. So that's why whenever we are using in machine learning applications or pattern recognition applications. So in that case, we have to take limited samples or in a limited domain.
Right. Actually, no. One of the things. Yes. Yeah. Go ahead and finish. I'm sorry for interrupting you.
Certainly.
So you finish your question?
Yes, sir. Yes, I'm
okay. So, I was telling earlier, not only for students and faculty members, if they want to work on a research problem like this, we have really lots of resources, computing resources. And often I complain to faculty and students that they're burning so much electricity, but we're not using them. So I don't think we are over utilized our resources. So if you all want to work on a project, I need to do some paperwork. So say that why this person need access. So we could provide access to computing resources that GPU intensive computations. We have two specialized computers, and one is called IBM Power. I think it's called Power Station, which is specialized for neural networks and machine learning. We also have DGX, NVIDIA DGX one station that's also specialized for AI and machine learning. So if you want to work on vision problems, natural language problems, any that are compute intensive, that we could work with you by providing the resources. So that what I wanted to say is, you think big, interesting problems, and you don't want computing resources to be a constraint, right? So I can take that responsibility to provide computing resources. It's a win-win, right? It's nice to do international collaboration. Publish things together, so it will be good both sides. Okay.
Over to you, Gil, sir.
Sonny? Okay, any other questions?
No, sir.
Okay.
So thanks.
Yeah, go ahead, Dr. Archana.
Yeah, Dr. Venkat Gudivada, for very insightful and wonderful session. It made all our concepts of machine learning very clear. So thanks a lot for your efforts for this session. Now I would like to request our director madam for her comments, please. You are mute, madam.
So I don't think I'm all that eligible to comment on the lecture conducted here by Professor Gudivada. As I don't belong, I told you that I am a mechanical engineer, but I have enjoyed the session. I could understand to a major extent, I should say, because it was explained very well. And I'm sure you all have enjoyed it more belonging to the computer faculty. I mentioned only a couple of our senior faculties, but I think Dr. Archana is blessed with the whole team of very special faculty members. Like Titre looks after the training and placement, working very hard. Ejaz sir looks after the website matter, works very hard. Mohsin and himself, they work behind the screen. Then including Pankaj Pawar and Neetu Pariyal, they are also very popular teachers. Then Savita Vagre and Chennoji and Jyoti Kale and Nikita Pandey, Bhandare, and the youngest of all, Miss Anjali Hazari. She came with the turmeric marks yesterday. So I think that along with senior faculties like Shastri Madam and Jyoti Madam, like you have all special colleagues with you working hard along with Rahul and Junaid, whom I mentioned. So
Right.
like the whole department is very special, works hard, and you have a long way to go, and keep organizing such activities more in future, and put your students to advantage so that the students passing from computer engineering department in particular will be specially recognized in the corporate world. So
Thank you, madam.
yeah. So,
Yeah, really
Gudivada,
blessed.
thank you so much.
My pleasure.
I think Archana had been to some conference to Mysore. Is it Archana? You had been
Yes,
to
madam.
Mysore, where you first
Yeah.
heard Professor Gudivada, right? And
Right.
Yeah.
then I frequently used to hear your name through Archana.
No.
So then she mentioned about inviting you for this conference we organized in December. So like I was very happy that you are coming to our campus, because that was a long cherished trip. And
Thank
not only you have come for the conference, but you have taken out such a time for all of us and have engaged yourself in conducting these webinars also. I hope and I expect that this association will go a long way. And I'm very happy to announce that Professor Dr. Ajit Abraham, he had come from MIR labs, Machine Intelligence Research Labs from Washington. So he has sent MOU to Archana Madam, which she has shared with me in this morning, that they want to get associated with our institution.
Wonderful.
So I'm happy to announce that we will announce. We will have MIR labs associated with us, and we'll try that we do something to their expectations, and will contribute in the practical projects that are given by MIR labs.
Right. That'll be a good starting point. Yeah.
Yes, sir. Yes, sir.
Right. So, you commented about, I think, we met Dr. Archana in 2006. She came to a conference in Mysore. Dr. Guru organized that conference. I think before that also, I think we had email interaction. We had not seen in person. I met her advisor, Dr. Joshi. I think it was in 1995. He came to the United States, and I used to work at University of Ohio. So he came to our department because one of his students was a faculty member there. So I think from that point onwards, I think he was mentioning about Dr. Archana's PhD work, and he wanted to collect some papers in image retrieval, content-based image retrieval.
It's a great association.
My pleasure. I think you're doing the right things. I kind of think of mechanical engineering, electrical engineering. I think there's a lot of opportunity to really work together with computer science. So the probabilistic graphical models also have lots of applications in mechanical engineering, electrical engineering. Yeah. So I also want to say, you all people have really, no matter what's going on, you have, all of you have smile on your faces. That's a really great quality to have. I try to kind of, remember that, from my visit. I think, no matter what, I think if you can work with a smile, that's the greatest, gift, that one can have. But Dr. Gillen, I see he was, when they came to the conference, he was so instrumental in, helping and doing things. And I remember all of you, Rahul, and to me, when I do this, it's more like, I'm so close to all of you.
Yes, Dr. Gill has recently joined us, but he has become a backbone for everything. Conducted online now in online exams and all. He has helped a lot.
Right. You have really
Happy to
dedicated
have you
people.
with us. Yes.
Yeah, right. Okay, so any other questions,
Credit of
comments?
our smiling yeah, the credit of our smiling faces goes to our director, madam. She has created such an environment that every one of us enjoy working with her.
Right. That's wonderful.
So I request now Rahul
Yes, ma'am.
for vote of thanks.
Yes, ma'am. Hello, everyone. It is my privilege to have been asked to propose a vote of thanks on the occasion of webinar on interpretable machine learning with probabilistic graphical models presented beautifully by Dr. Venkat N. Gudivada sir. As it is said, no matter what life sends us, we are responsible for the way we respond. Department of CSE at MGM's College of Engineering understands its responsibility in this COVID-19 pandemic and responded in positive manner, utilizing this lockdown period by arranging this international technical webinar. And it was all possible because of the inspiration fueled by our respected director, Dr. Geeta Latkar Madam. I feel obliged to thank Director Madam for always being there as our support system. We all know that Dr. Archana Rajurkar Madam is HOD of CSE department. But do you know what is the full form of CSE? It is consistent, sporty, and energetic. I take this opportunity to extend my heartfelt gratitude to head of CSE, that is consistent, sporty, and energetic department, Dr. Archana Rajurkar Madam, for her determination and hard work. I deem it a great honor and privilege to express my sincere gratitude and appreciation for the speaker of today's webinar, Dr. Venkat N. Gudivada sir, for completing our dish of webinar series by adding not only salt, but also serving us with a sweet dish of machine learning. Sir, you charmed all the participants with your amazing knowledge. We look forward the same help and support from you in future also. But last but not the least, I, along with my co-coordinator, Mr. Junaid Khan, and student team, Samruddhi, Abhishek, Kartiki, Gargi, Nikhil, and Sumit, thanks all the participants who had spread their valuable time to attend this webinar. I would also like to thank Gil sir for his valuable help and guidance throughout the webinar series. I also thank all those who directly or indirectly contributed for this webinar project. Thank you. One more thing, I want to give a short announcement that the participants have to fill. We will be sharing the link of feedback form in the chat as well as on the YouTube. You have to just fill the feedback form or give their valuable feedback so that you can get a e-certificate directly on your mail ID, registered mail ID. Thank you. Over to you, ma'am.
And we all thank our management and our chairman being behind us for organizing all such activities and like giving us all the energy we need.
Yes,
yeah. So thank you all. And it's always my pleasure to be with you. So we look forward to some other opportunities. And if you have any students, faculty interested, I'll be happy to provide whatever is needed.
You won't be able to get rid of us ever, sir. We will be after your blood all the time.
No, that's fine. It's a mutual, right? So it's mutually, beneficial. So I also enjoy working with you all. So it's I also feel it's it's a one way to be connected to India as well.
Thank you, sir.
Yeah. Okay. So you all have a good evening.
Yes. Yeah. And you have a good day. And please keep coming to us in future also.
Sure.
This lockdown will go over.
Sure. Yeah. Okay. Thank you. Good night. Have a good day. Bye now.
Yes. Bye, sir.
Yeah.
Thank you. Thank you, Professor.
Bye.
Thank you, madam.
Yeah.
Thank you, ma'am.
So, Rahul, shall I leave?
Yes, ma'am.
That's nice.
Thank you, ma'am.